Thanks, everyone. So, math, subset algebra, subset linear functions. So if you haven't already done this PDF, please pause the video, go work through the 10 questions on your own first, and then come back for the walkthrough, okay? All right, if you're still here, I'll assume you're ready for the walkthrough. Let's do it. Okay, sometimes they give you a pretty picture. What do we have here? So the graph is giving us the total charge in dollars by an electrician, cool, for X hours of work. So X represents hours, apparently, right? Good. The electrician charges a one-time fee, and hopefully you can sort of see that very easily. Let me get this going here. Yeah, the one-time fee would, of course, be the y-intercept right here. One-time fee. Plus an hourly rate. What is the best interpretation of the slope of the graph? Rather than directly answer that, I want to point something out here. For linear equations, which are always about y equals mx plus b, notice how, let's do this. Yeah, here we go. Notice how the total charge, like how much the money would be, how much money the person's going to charge, that's clearly going to be like the y value. Whatever point you find, you're going to look at the y value for the money, right? And money would be an amount that somebody charges. The idea, by the way, that there would be a maximum amount is crazy. You could you keep hiring him, he'll keep working. This is not a curvilinear thing. This is a line. So where I was going next is to say that there's a one-time fee, right? And that's clearly the y-intercept. The one-time fee is going to be this. The one-time fee is going to be this. So that's the y-intercept. So if you have a y value, that would be the amount. If you have the b value, that's the intercept. If you had an x value, which would represent a certain number of hours, like if that were an answer choice, the number of hours, then that would be wrong. So if these three are wrong, notice how we can find our way to the correct answer without actually even understanding it. Okay. So again, just to be super clear, here we go. Yeah, so the x value would be like time, right? And the thing left would be the slope. And of course, the slope of the graph would be, for every hour, how much should they charge? Hourly rate. Okay, I spent a lot of time on this. There's a couple of ways you could do this. One of the ways is to just recognize, well, of course, the slope is like something per something, x per y, or dollars per hour, I guess y per x, right? How many dollars per hour? The slope is always going to be like y divided by x. So you could just know that it's a, but even if you're not sure, you can find your way to the right answer by eliminating wrong answers. It's a powerful tool on the PSAT and on the SAT. All right, snow leopards. What's up with snow leopards here? Let's see. All right. Population of snow leopards is this thing defined above, where PT is the population T years after 1990. So there's a couple ways we could do this. Why don't we give this a try here? You may remember from earlier videos that doing things like P of T, it's going to start asking you to add sliders for everything in the world, and we don't want that. So let's just go like this, P of X. It doesn't really like that either. Why don't we just call it F of X? Actually, so, okay, let's try P of X. I want to stick with that for a second here. Equals 250 plus 10, and remember not to put T because it's confusing. Put the X. Okay, it looks like we're okay now, except we can't see anything yet. So if we zoom, here we go. Yay! If we zoom, we have something here. Okay. Let me do this just so we can see this a little bit better. Okay, so here we have a graph here. Because this is a real world problem, we have kind of an issue here. It's talking about the population T years after 1990. So that would clearly be like time zero. So if we zoom in a little bit. By the way, if we click here, do you see the 0, 250, right? Well, that's clearly the y-intercept. And then the 10t is talking about for every year that passes, our slope is 10. So when they want to know what is P of 30 equals 550, let's just take a look at that, maybe. By the way, P of 30 does equal 550. That's exciting. And let's see if we can find that. P of 30. I wonder if it's doing. No, it's not going to show that actually. Interesting. Okay. Desmos is fun. So 30 would be here, P of 30. And if we go like straight up and down, more or less, eventually we'll hit the 550, right? Hopefully you see what I'm up to here. P of 30, P of 30, P of 30. There we go. So if I kind of zoom in on this spot right here, hey, it will, no, stop that. Hey, it will let me click on there. Okay, so you get the idea, right? There we go, there we go, there we go. 30, comma, 550. So when the time is 30, the leopards are 550. Again, when the time is 30, like 30 years have passed, you've got 550 leopards, okay? So 30 years after, what was it, 1990? Yeah. We have 550 leopards, leopards. Good, leopards. Is it predicted to be 30, the population? Ew, no. Is it predicted to be 550? Why, yes. Why, yes. What year? Not in the year, well, let's see. What's 30 years after 1990? 1990 plus 30 equals, and depending on how tired you are that day, there's no shame in going like this. Thank you. It's 2020. It's not 2030. Something about like the 30 sometimes tricks people and makes them pick, answer choice D. But the calculator or correct calculation in your own mind, paper, gives you this answer. Okay, cool. So far so good. We had we had some interpretation to do here. We had some like translation interpretation to do here as well. So sometimes the linear functions kind of do that. Other times, well, no, 3 will be exactly that, and then with 4, we're going to get more into just good old graphing. Okay, so let's interpret one more first. Okay, here we go. Okay, so apparently we're getting energy per gram expressed in 2 different ways of the 3 macronutrients in food, whatever those are. We don't need to know. This is not science. We don't need to know. It doesn't matter. All we know is that X food calories is somehow equal to K kilojoules. Okay, so apparently this is representing the X value, and this is representing the K value of kilojoules or whatever. So what's the relationship? Okay, in this case, they've literally given you a couple of points, right? By points, what I mean is, let's see here. Sorry, let me just see one more thing here. That's fine. Yeah, that they're saying that there's some relationship between like K and X. What's the relationship? So instead of talking about X food calories, we could talk about 4 food calories. So everywhere there's an X, we could put a 4. Everywhere there's an X, we could put a 4. Okay, good. And everywhere there's a K, we can put a 16.7, 16.7, where there's a K, 16.7, where there's a K, 16.7, where there's a K. And finally, sorry, let me move this over here. There we go. So wherever there's an X, we're going to put a 4. Wherever there's a K, we're going to put a 16.7. Just looking at that last one, do you all agree that 4 times 16 is a big number, and that's not going to be 4.2? And same with C, 16.7 times 4.2 over here is not going to be 4. That's just not, no, that's not the case. Could it be that, 4 times something a little bit bigger than 4 would be a little bigger than 16? Pretty plausible. What about 4 times this tiny. No. Okay. So even just like eyeballing it at this point, you can tell it's B. If you need to, use the calculator. The overall strategy that I want to talk to you about here is that if they give you points, like the protein 4, 16, 7, 9, 37, this should work with yeah, it should have worked with, it would have worked with any of the terms. I mean, carbohydrates are literally the same numbers anyway. It would also work with the fat. The point is, if they ever give you points, what you want to do is plug in the well, plug in the points. That doesn't sound very good. I was gonna we have when it's plug in the answers, it sounds nice. It's PETA. So let's just say plug in points. That'll be the mnemonic. Okay, that's the strategy. Rather than try to figure it all out yourself, just take a point and plug it in. Oh, this is nice. Yay. Okay. So apparently the graph of the equation contains 2 points, which means we can use a table. Let's do it. It's 0, 2, and it's 8, and it's 34. Yay, good. And I'm zoomed way out, so let me do this. So 0 and 2 and 8. Okay, good. So you all see the points, right? In other videos, we created, these regression things. I want to try something slightly different. I want you to see something that's even a little faster. Take a look at A, which says f of x is equal to 2x, what, plus 42? Cool. Does that look right? Does that look like that's on the line? No, it doesn't. That means A is wrong. Get rid of it. Now I'm going to make it 32x plus 36. Does that look right? No, that doesn't intersect the points. B is wrong. Get rid of it. Let's see, 4x plus 2. Does that look right? Yes, it does. That's our answer. And if you want to check just to be sure, check out the 8x. That's wrong. Clearly it's C. Yay. Okay, how efficient was that? They gave you points. So put the points on Desmos. And in this case, we didn't really need to like find the equation. Just try them out. No big deal. More word problems, yay. Okay, according to a model, the head width in millimeters of a bumblebee. Oh, okay. The width can be estimated by, so width equals, by adding, oh, this is annoying, so I'm going to go width. Let's do that, yeah. By adding 0.6, so we're going to add 0.6 to 4 times the body weight of the bee. I'm going to make that B for body, okay? You don't want to have 2 W's. This is annoying. Okay, so the width is 4B plus 06. Any questions about that? Well, if you do, I'm not here. I can't answer them, I guess. Okay, but hopefully this makes sense to you, right? Now, according to the model, they're saying, well, what's the deal if the body weight is this much, 0.5? I don't know. Let's find out. So it's going to be what? 4 times 0.5 plus 0.6 is equal to 2.6. That's the answer. Any questions? If you do, email or chat me. But I assume you won't have any questions. This is exciting. Okay. Think about, for number 6, how you might have approached this in school. Think about the fact that we're now going to throw that out of the window. We're going to literally just do this, okay? See if I get that right. Always double check. Yep, that looks right. Okay, so we have our equation there. That's great. Wait, what do we have to do now? Not much of anything. We find out what f of 9 is. Or rather, we just type that, and the answer's 2, and we're done. Literally all we have to do. Desmos is very much your friend on this test, okay? I mean, for how many questions? Well, let's see. For these 2, we had to think and stuff. For this one, it was a mixture. No, we didn't really need to. You could plug this in too, but anyway, for 1, 2, and 3, we had to actually think. For 4, just pure Desmos. 5, we used Desmos as a calculator. You didn't have to, but for 4 and for 6, Desmos is just crucial for like speeding you through and getting you the answer without any doubts whatsoever. All right, I'm suspecting this will probably be the case for 7 as well. Let's find out. So we have a new function. Excuse me. Okay, well, that's interesting. So there's all these constants all over the place. That's kind of annoying. Let's do this. I'm going to go ahead and say yes for the sliders. tells us that f of O is 18, and you're going to say bet. It's not doing that though. Okay. I get the issue here. I mean, I can sit here and decree that f of O is 18, but it's like, are you sure? Because this line is like all over the place. It could go anywhere. I don't know. Let me put it back here. There we go. So, what does f of O equal 18 mean? That's exciting. Try that again. Okay. It means that one of the points would be 0, comma 18, right? And so that would be there. And the other point would be 1, comma 20, right? And that would be there. Great. So right now, yeah, the function is not doing what I want. So let's make it do what I want. Basically, drag anything. Okay, if you drag this, it's going the wrong way. If you start dragging this, you're going in the right direction. Hey, come on, keep going, keep going. If that happens, click on the 10, just make it bigger. It doesn't have to be that big, probably, but let's find out. So let me zoom in a little. Okay, so now I'm at least going through 018. So that part looks good. But the slope is off. So let's grab this and start playing with it. You can do this and this will be bad, and you can do this, and then it's like, hey, wait, we're almost there, we're almost there. Come here, you. We're so close. Okay, look. There we go. Now we can confirm the equation's going through the 2 points that they give us. Notice how they gave us 2 points. And so I'm going to say again, what we did in a way is we plug in points. In this case, we just plug them in directly into Desmos. Plug in points, do your f of x equals mx plus b, drag things around until you find that b is 18 and m, which is what they want to know, is 2. Cool. Hey, look at this, everybody. 2 ways you could do this, by the way. You could literally say, okay, they said that there's a point. You're like, bet. There it is. And you say that there's another point. Sounds good. Don't see it. Where is it? There it is. Lol. Good. We're good. Which equation defines x? Yes, you could do a regression, but depending on your mood, you could also just put in the first answer choice, 28x, 34, and look at it and say that's wrong. Try B, which is what? Nah, that doesn't look good either. How about 4x plus 3? Yeah, that's the answer. You want to check just to be sure? Yeah, that's wrong. It's clearly 4x plus 3. Thank you, Desmos. Thank you, Desmos. Thank you, Desmos. Sensing a pattern? F of 0 equals 8, which means this, right? You don't even have to label it. F of 1 is 12. 1, 12. They're just there, right? Good. Which equation, zoom in a little, which equation defines F? Well, I don't know. Let's find out. Not that. Not that. Not that. D. Thanks. Desmos. Desmos is your friend. And as we begin, so we shall end with interpretation. Right? Remember, number 1 back here was, hey, here's a graph. How do we interpret all this? So now number 10. Okay, here we go. Interestingly, I'm just side note. If you ever get a visual graph like this, and they kind of do low-key have a couple of very clear points here. They have like, 0, 100, and they've got this like 2 and 150. You could, if you needed to, put those points on the graph and find the equation and all that. But let's see what we can do first, just, giving it a read. All right, so we have a total cost, Y in dollars. So here's the number of dollars, Y dollars, for a certain video game system and X games. So X is the number of games and Y is the number of dollars, right? And again, they want to know the slope. Okay. Well, let's see here. Oh, right. Yeah. There's a video game system. The cost is for a video game system and X games. In terms of Y equals MX plus B, Well, we've got our Y value, which is a certain, it is like a total amount of money, I guess, right? The total amount of money. None of the answers say total amount of money, so that's fine. X has to do with the number of games. None of the answers do that either. That's exciting. There's that 100 at the y-intercept. Well, that's clearly what the game system itself costs, which makes B a really nice trap answer because it's true. The video game system costs $100. But if you make sure that you read the final question, RTFQ, boom, 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 read the final question, they want the slope. This is the B value, right? Answer choice C is an incorrect version of the B value. So it's wrong for that reason. Both of these are basically the B value. How much does each game cost? Each game. Oh, this is exciting, actually. Okay, good. So to find out what each game costs, we kind of do, low-key, need to figure out what the slope is, don't we? So if we take this point of 0 and 100, okay, 0 and 100, let's do it. And now I am going to pull this up again, the table. 0. You can probably do this without, but let's just show you how to do this using decimals anyway. All right, and then it looks like actually even here, right, at one game, one game, one game, it's clearly halfway between 100 and 150. So that's clearly one. Here we go, 125. Okay, good. Yeah. There you go. There we go. Here are the 2 points, right? I know it's the slope is a little off in terms of like how it looks, whatever. Anyway, long story short, given that the points are so close together, it's pretty easy to see that as you go over one game, the rise is $25. So apparently each game indeed costs $25. Answer choice A. Okay, Desmos is your friend. That is all. See you with the next exercise.